So this is a clear example of multi-threading. All right. So in the main, we created an instance of this. First, we did what? Thread. We implemented the runnable class inside thread demo, and the only method we implemented was this run method, which is of a thread, which is also in a thread class. Basically, what we are doing inside the run method is just to what? Print lines, a running thread. That's just what we did. And after that, we go to the main and created an instance of it, of that thread. We have two ways of actually creating a thread. Number one, that we implement the runnable, or we extend what? The thread class. If we are implementing a runnable, we must pass that runnable into a new thread class as an object before we can create a new thread object. And before we start the object, during the starting, then after we starting on a norms, a conventional programming, after this runs, the next that runs is then the next. But somehow it's interesting to know that this jumps into each thread. That's what we've been doing, and that's what we still do. This is going to lay foundation for the next example. Are we good to go? Let's move forward. We've done this same thing before. Created a worker that extend the thread, and then in the main class we created an instance of it. We start it, and inside this T1, while it is alive, main thread working, then sleep every every while it is alive, or if it's half, it should be printing every half second that worker is what is working. So we are trying the is alive function. The dot is alive. Now that's what we want to try. So quickly inside the main thread, I believe you have done this. Now we want to create another one, alive check. Create another class called alive check. No, let's call it worker. Let's create a worker. Sorry, class worker. And it's going to extend the thread class, of course, because we want to use it to create extends the thread class. And then what are we doing? Of course, if it's extending the thread class, it must what? Override the run method. Then what are we doing in the run method? What we are basically doing in the run method is to after every we are just printing working one, working two, working three after every 5 seconds. Let's just for I int is an integer I. It's initially it's 0, then I is less than or equal to 3, that's from I to 3, then I plus plus, that's to increment I by 1. What do we want to do inside this for loop? We basically want to set worker warning. Okay, system print line gets name and worker. We want to get the name and the worker. So this system print line gets name and working. Okay, worker name and what plus after that, then comma, then plus um worker name plus we're adding it to the thread name, that is get name plus get name. Then after that we add a space and we add it to it gets what gets, we add it with I. Let's just add it with I, that's all. Can just say okay, process count. So at every it will be looping 1, 2, 3. At every of them, let's pause for let's pause for maybe 1 second. 1 second. How do we do that? Say thread dot what? How many minutes do you want? Want 100 milliseconds or 1,000 milliseconds? Because anytime we are doing this, we must wrap it with what to go? Must wrap with try catch, and we should be able to get this quickly. Let's catch up. Hmm? Because it's if see there is a thread. The thing that causes interruption exception is basically sleep. You understand? Sleep, all those major things that makes a thread to pause causes them to stop. All those things are they're always through illegal state exception. If you tell this thread to sleep and there is I mean not ILC, there is interruption exception. If there is anything that makes it to stop, it will throw interruption exception. So the only all those process that starts and all those things. But other methods, other extensions like IELT interrupted. Sorry, what is that in illegal states, illegal thread state exception ISCLT. Those ones are just when you want to start a thread that is already alive. That's that. Then after that, let's call it inside the main and said, where's our main? This is our main. So I'm going to comment on this one, flash to comment. So I'll start a new one. I'll create a new worker called a new instance of thread demo. Is it thread demo or worker? I'm going to call it worker. So new created a new instance. That creating that instance will start then in this loop. So long as that instance is alive, we'll be printing this. So said worker dot what start to start it. We want to be printing something so long as this thread is alive, so we know that there is nothing that have interrupted or stopped this thread. So we just say worker, let's do for a loop, worker dot is alive to return true or false. If the worker is alive, Mm-hmm. It's not be used while, sorry. That's wrong. So while this is this, it's out. Let me open that up for please. So that's about that. Yeah, I'm good. He wants it on. No, I just thought that time that there was no power. So, and we sleep afterwards, 5 seconds immediately after that. Is it the thread dots what sleep? Which thread are we sleeping? Or this main thread? How many seconds? 500 milliseconds. Of course, we want to wrap it with what try and catch. So that's about that. Then print it. So you run this. See the thread name is 0, process count 0. Thread is still working. So long as this thread keeps working, it will print out that. But after this thread is no more working, so it's no more alive. So the loop breaks. So that's about that. Then write a program that starts two threads and uses is alive to print their status before, during, and after execution. Everybody, let's get this done. Basir, everybody, let's get this task done. This one, worker. So we're done with it. So the join method, it makes a thread wait for another thread to finish before continuing. Can tell that worker to wait too. So for example, when you join, if you start with the word, these are the syntax. You can either without passing any parameter, you could pass out, you could call it with passing the milliseconds, the time it should wait, or we could pass both the seconds and the milliseconds and the nanoseconds that it should take to wait. So see that the other three ways you could use join. Hmm? To reflect. Reflect what? Reflect on past terms. Okay, like what we have done before. We do. Okay, yes, 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 yes. Oh yeah, we are going to do that. We will do it, of course. So the join waits till another thread finishes completely. Then this one waits for a given millisecond, then continue even thread is not done. This join with timeout it adds nanosecond precision. In case you are using precision, you can add nanosecond. So you can do the example. For example, we are counting that one. We are counting. Let's improve this other code. This our worker. Where is our worker? On our worker class. Okay, it's already counting from one. Waiting for. I think it's okay. Let's leave it like that. In our worker class, we create we create an instance of it, then join it to the main one. We start it, then join. Then we say main thread resume after T1 completes. Main thread resume after T1 completes. So if we come here, where is the main thread? This is the main thread, right? This is where we define the main thread. Main thread. This is the worker. Okay. Quickly, we are not looping anything here. So let me comment this one. So after we start, then we said worker.join. Welcome. Why are you coming by now? Okay. But you didn't take permission now. You know the rule, right? Abi, you came to greet us. You came to greet your people. You came for class. Okay, she gave you permission to go. That you will be coming late after your class. Let me call her. Let me message her. Let me see. You're welcome. Hello. Hello. Yes, hello, ma'am. Prince said,
It's Jennifer.
okay, Prince said, is Madam there?
No, she went out. But did he say he sent it to her? Because this number, and I did not send anything. There is no.
It's whether did you send it on WhatsApp or you told her directly? That's they already knows. That's what I want to know now. Because they already know now. Is it that you told her on call or you saw her live and say you'll be coming today very late? I want you to tell me how you told her so that she already knows.
Wait, I'm coming upstairs. I'm coming upstairs.
Eh? So thread or join. See, the guy is not serious. He said that he took permission from Madam that she will be late today. I don't know. He said he already knows. She already knows. She already knows. He's speaking calls. You came late, very late. That you be coming late. All right. No, does she know that you're coming late today? The system always have issues. We know that. Even me, I know. Okay, you didn't tell her that you're coming late today. See, your time, you didn't take permission from her, right? That you are coming late today, did you? Please, you can you continue the class tomorrow or next time. We can't just allow, you can't just walk in like that. It doesn't work. It doesn't work at all. The least you do, is at least chat me on WhatsApp, and that I would understand. At least that you took permission. You call or you send your brother. There are plenty options that you can do, right? So coming like this by this time, this is a class of what, 12, right? You're coming by 1:30 and you're comfortable that the manager already knows. That is too much now. Come on, right? Mhm. So please, let's just try to start learning our own self-disciplines, right? Next time, at least the least you do, if you don't send your brother, you write a message. I would understand. Please, it's not right. Then we added join. This waits for the main thread. Why does it wait for the main thread? The main thread is the one calling this method. So if this main thread does not finish, this one will not run again. T1 will not, worker will not run. So a main thread resumes after T1 completes. Wait, where is it? Where is the dot join? Oh, right because this is try cat. Let's move this worker. Does everything is so? Create a new instance inside this worker. Let's run this thing again now. And you see this one is working. So did we do any major thing in the main thread? The main thread, no, we didn't. So let's just pull this out. After we join, then we'll continue this. So the main thread is on pause, waiting for this one to complete. It's just like async and await in JavaScript, right? You await for the thing that you join to finish. That was why this one came out after this whole worker after this worker ends process, then thread 0 is still alive. Is that what we said? Yeah. After this whole process finish, then we do this. So this waits, this main thread is waiting for this worker to complete before before it continues. For example, this place without before being paused. After being paused. This is before being paused. It's paused now. It's wait till what paused it completes. And how do we pause? We just use dot join. Is that clear? So the dot join is it's just dot no, it's just like you inside this main thread. This thread will complete before you continue. Where you call it, the thread you call to say dot join will complete first before this other the other process in this thread that I called it continue. So that is immediately reach this line, whatever is happening before stops in this main thread until everything inside workout is completed before the next thing. So that's about that. That's about the dot join. So we could add timeout as well, or so let's increase by adding timeout. Let's create a new file called join timeout example. Joint timeout example quickly. I want us all to do this example, right? Create a new file, joint. Let's get used to this. Joint time out. Java. This is where we are going to demonstrate our joins and timeout. We good? Should we fire down? So let's create a new worker class. This one is just a task. We call this worker task anyway. We are looping from 1 to 5 and just printing something. We are not waiting for any, we are not sleeping. We're just counting from 1 to 5 and printing the name and the count. Call that is a task. So quickly, let's create a task. So we create a task class. Task is going to extend thread, right? Then of course we are going to override the runnable, and what we will do is just use a for loop to count from 1 to 5 and print the name of the thread and the count out. So for loop int I is less than or equal to 3, I plus plus And what we're basically doing is to sort. What we're doing is then I from task task, then plus get name to get this name. Then we are adding it to plus another empty string. Initialize it to be 0, the I, sorry. Then get name, then you can put count, then put I. That's what we're just doing. We're getting the name and count of the process. No, we're not specifying any sleeping, any waiting time inside it. Hmm? Yeah. What to know? So should we get going? So you just created the worker or the task. Now, what are we going to be doing in the main example? Inside the main example, we'll just create an instance of it, right? Then a new task. We'll create an instance of a new task. Then start it and join it. All right. Another thing you might want to know is if a function that returns or don't return anything, it could have you can also determine the default exception rules to any method by putting what throws interrupted direct exception instead of wrapping everything with try and catch. It is a method or a function, you can always throw it. So we could add throws. Where is that? Inside our main. Can just put the throws this exception. What is the name of the exception? Interrupted exception. Yes, interrupted exception. Sorry. Inside main. So int main. Let's put the main method here. Then by default we'll put throws. It's supposed to be inside the function method. But I've created it. So instead of wrapping everything with try and catch, so by default, anytime this method is called and there is an exception that happened within that method, we should catch it. We are by default saying it's going to be interrupted exception because we are basically perform a thread operations here. So quickly, you say okay. If you you might choose to do this or not. There are sometimes a method that we talked about exception the other time, that sometimes many method throws exceptions. This is a function. A function has what the access modifier, which is public and static. Then it has a return type, the function name, and the parameters that is passed into a function, then a curly bracket. But also there are sometimes if you call this function, there is you are expecting a type of error that could happen, right? Like, okay, I'm expecting that sometimes user might not put this anytime we call this function. No. Okay, because we're anticipating that error, let's wrap this method to make sure that in case that error happen, we throw that type of error. That is when you pass the through, and it must be on a method, right? And you put it directly here and it will throw that error. But in the case you don't use this, watch now. I want you to watch something. If we don't use this and we just do normal, we create an instance of task, type task, called task 1, equal to a new task and end, and we'll say task 1 dot join is going to tell us to wrap inside try catch, right? Which we usually wrap inside try catch to avoid this error, right? But in the case we don't want to wrap this plenty try catch error, and the reason why we are wrapping it is expecting us to wrap into try catch is because there could be a case this task might be interrupting sub, so we will cause interruption exception. So we just say, okay, oh, let all this method be focused on those thread things. So we just throw it here. And if we did this, we do not need to do this try and catch anymore. Is that clear? So by default, we have handled our functions, even error expectation right here. Are we good? So we created a new task. We started it and we joined. Let's start and join first. Let's start before we join. Task1 dot start. We started it. Then after everything we joined, then we main thread resumes after T1 completes. We just write south main thread resumes after, can just put plus task1 dot get name. Remember get name now, plus is completed. So we can set the name here to make it more fun. Task1 is equal task1 dot set name. Can set a name. What's the name? Let's say Basir's task. Basir's classwork. That is a task name. So if we run this, we are not, everything is happening fast because we are not waiting. So main thread resume after Basil's task is completed. So Basil's task is the day because we gave it as Basil's task. So this task1 is Basil's task. So we say task Basil's class work count. Count is this. Basil's class work. Okay, we should give a space. Basil's class work. Basil's class work count from Basil's class work. So he's doing all the class work. Perhaps to me, he's waiting for Basil to finish his tasks. Then you can use the task to build on her own. All those kind of a thing. So it's just like await in JavaScript, right? But the nice thing about this one, you can await with even, you can add the time Like say I want to wait for how many seconds as well. You can add the timing that you want to wait. That's the nice thing about this. Using the join method. That's what we're trying now. You see? Can I go back? Okay. Hmm? You see? Okay. We're good to go, right? Hmm? Okay. So that's about that, right? So let's do a little bit of this last example, but this time around we are passing in a time like one waiting time. Wait 1 second only. There's no waiting for, just wait for 1 second before you continue. You understand? This one, yes, the thread will continue working, but the thread that is calling it will not totally wait for it to complete. Even though it didn't complete, as far as it waits for this set time. So thread does sleep. So aside that, we thread does sleep this. So quickly, let's improve this a little bit. So after this count, we do thread dot sleep, and the duration is 4,000 milliseconds. Let's wrap it with try catch. Right. Then this join now, we are not waiting just endlessly for it to finish. We only wait for 1 second. So after 1,000, we're done. You say right. Let me stop it first. This 4,000 is too much. Every 500, every half second, do this. This is going to wait after the two process. So let's run it. Wait for for the 1 second we give it, then continue its main process, and this other one continue anyway. Exactly. So it waits that 1 second, then it does what he wanted to do. He was waiting for this guy to finish. The guy was still continuing, so we only specify that you're waiting for it 1 second, right? So that's about that. That's just the improvement. You added 1 second to this, then added thread.sleep and wrap it with try catch after the system.out.print. That's just the improvement. So this one is just accepting time. Exactly. We good? Hmm? We good? Alright. Remember, we good. Tell me what's the problem. Concurrently, okay. Even okay, it's when this other one finished. That's when the this one. Uh, did you do this join with you specify the time within it? Sure about that. So that's about that. Let's say create three. This is your class task, everybody. Before you go, create three tasks, three threads, T1, T2, T3. Make main wait for T1 to finish, then T2 and T3 together. Make main wait for T1 to finish, then wait for T2 to finish, then wait for T3 together. No? Does that English? Then start T2 and T3 together. Okay. After you wait for this T1, then you start these two together. Observe the order of execution. Everybody get this done. Or you could use this other one. This your thread. You can use this one as what you are creating instance from. But create three. Everybody must do this one.